I'd like to do an example with linear functions. So let's look at this situation. By noon, 3 inches of rain had fallen during a storm. Rain continued to fall at a rate of 1/4 inch per hour. Find a formula for the linear function f that models the amount of rainfall x hours past noon. So here we have a situation where we have a certain amount of rain that has fallen already, and then a rate at which rain falls after. Now, this 1/4 inch per hour is the rate. That translates to the slope. So every hour that goes by, we get 1/4 inch more rain that has fallen. The 3 inches, this can be considered the initial amount of rain. So at time equal to 0, or in this case at noon, we have 3 inches that has fallen already. So we can write down this linear function, which will have the form f of x equals mx plus b. The m will be the 1/4, and the b will be 3. So the linear equation for the system, linear function, should be 1/4 x plus 3. All right, and now we can use this to talk about this situation. For example, let's say how much rain has fallen by 3:45 p.m. All right, since this function gives us the amount of rainfall in inches that has fallen x hours past noon, we just need to convert this 3:45 p.m. into hours past noon. Well, 3 o'clock, we ignore the 45, is already 3 hours past noon, and 45 minutes is 3/4 of an hour. So we want an x to be 3 plus some 3/4 of an hour. All right, let's make this one improper fraction. So we can convert the 3 into quarters by multiplying by 4/4. That gives us 12/4 plus 3/4 gives us 15/4. Okay, so 3:45 p.m. translates to, in our function, as an x value of 15/4 hours. All right, let's go ahead and solve the problem here. How much rain has fallen by 3:45 p.m.? Well, that'll be our function, f evaluated at 15/4. That's 1/4 times 15/4 plus 3. So we have 15/16 plus 3. And that's going to be 3.9375 inches.